All right, welcome back. Do you want to add wire network performance and stability to your home without tearing up your walls? Well, MoCA might be for you. Today we're going to take a look at this technology which enables you to use your existing coax wires for Ethernet communications. And if you're new here, hi, this is Sonoran Tech, where we cover a wide range of tech topics from hardware to home labs to coding and current events. If you like the content, hit the sub button and leave a comment to let me know what topics you're interested in seeing more about. So as much as we'd all like to have Ethernet running through our walls, that is a relatively new convenience limited to newer construction. And in some cases, even if you could wire your house, it may not be practical for various reasons. In my case, the house has no crawl space or attic, so the only option is to run wires through across the outside of the house or punch a ton of holes in the ceiling and walls to figure out where it's going, and that just isn't going to happen. Or in other cases, you may not own the property and the rightful owner may not approve of you punching holes in the walls no matter how good you claim to be at it. However, many houses still have coax wires running through their walls designed to support that dream of having cable TV in every bedroom, bathroom, and closet, because before the age of streaming, you needed to make sure you were front and center at the right time to catch the latest episode of Dancing with the Stars, and there's no better way to do that than having a TV everywhere you look. And that's where MoCA comes in. MoCA allows you to use these coax wires as Ethernet wires, delivering fast, reliable networking throughout your house without tearing up the walls. And yes, it will work alongside your cable TV service if you still have it. So let me step back and give you a high-level overview of how MoCA works. So MoCA, or Ethernet over coax, operates in frequency ranges that are specifically designed to avoid interference with cable TV and other services. MoCA typically uses frequencies between 500 megahertz and 1.6 gigahertz, which are higher than the range used by most cable TV services, which typically operate below 1 gigahertz, often between 5 megahertz and 1 gigahertz. This separation ensures that both data and TV signals can coexist on the same coax cable without interfering with each other. By using these higher frequencies, MoCA technology allows Ethernet signals to travel over the coaxial wires in your house while keeping the cable TV signal intact. And this is similar to how a coaxial cable can carry both video and internet signals simultaneously. MoCA operates in a more controlled frequency band, which results in faster, more reliable performance compared to Wi-Fi, while maintaining compatibility with the TV and internet services already running over the same coax network. But to really understand a little bit more about it, let's start with a logical diagram of how MoCA fits into your home networking setup. And then from there, I'll actually show you the installation in my house and show you what the devices look like and a bit about what the wiring looks like. So let's start with the logical view for now. I flipped over to the handy dandy draw.io screen. And let's just start with laying out what a home might look like. So let's assume you have cable internet service. It really doesn't matter. Let's say you have a cable modem bringing your internet into the house, and behind that you're probably going to have some type of router. It's possible you have an integrated cable modem router Wi-Fi device that you got from your internet service provider, but I'm going to separate them for now. So let's say behind this we have a unified dream machine, which is what I have, a UDM. Now this is your entire Ethernet setup. We'll get to Wi-Fi in a second. So the UDM is your router, and behind that you're probably going to have a bunch of devices connected to it with Ethernet wires. So maybe you have a PC, and let's just say maybe you have a streaming device like an Apple TV. We won't go too crazy with this. Now, of course, also hanging off of your UDM, you might have many Wi-Fi access points. So great. Very simple setup where you can have wire connections through the Wi-Fi access point, again, on a wired Ethernet connection connecting to your UDM. Now you can have wireless clients out here, like you could have a phone connecting over Wi-Fi. Great. So now let's say you have all this wonderful coax cable running through your walls. And one of the problems you might need to solve is hey, getting Wi-Fi to certain bedrooms could be a pain in the butt, or you just want the advantage of a wire connection, doesn't matter. But let's say you have a bedroom, and let's say over in that bedroom you have another PC, and you want to connect that to your UDM. You want to connect it to this guy right here using the coax wires in your wall, and this is where MoCA comes in. So the way it works is you buy a MoCA device. You're going to connect it to your Dream Machine just on one of the standard ports on the Dream Machine, right? Because it takes Ethernet on one side, right? And then to connect it to that PC all the way over there in that other room, you're going to find that coax connector on the wall where someone wanted their cable TV And what you're going to do is you're going to connect another MoCA device there, which you have to purchase. And that MoCA device takes coax in on one side, outputs Ethernet on the other side. Pretty simple. And now the PC over in this other room can connect to all these other devices and obviously get internet access through your cable modem going through the UDM with its traffic routed over this MoCA network. And what's happening is these two MoCA devices are communicating over the coax wires in your house using the previously described methods and signal ranges. Now, that's a pretty straightforward case, but you can get more complicated in there. Let's say you have many rooms. Let's just put this PC up there, and I'll describe a situation I have. So imagine you have a family room and you have several devices. You can have a streaming device like an Apple TV or a Fire TV. And actually, I'll show you, I have a wireless access point, and I wanted those on this network as well. So what you do is you put another MoCA device. So think of it as every place that you want to kind of bridge from Ethernet to coax, you need a MoCA device. So there is an investment. And then behind that MoCA device, I put a Unify switch. And actually, I'll just move this over because this probably reflects more of reality. I have an Apple TV and Wi-Fi access point. And so that Unify switch is connected to the MoCA device. And then that MoCA device is obviously communicating with all the other MoCA devices. Now, these lines are not a fair representation of what's happening, but I'm just showing them as fully connected at this point to get a sense of things. And so here, you've actually kind of extended your network over your coax to multiple different rooms, and they're all communicating on the coax wires with the MoCA devices handling that bridging for you. And over here, I have a Unify switch, and now I can hang, again, multiple devices off that if I want. And what you can do is, I have a wireless access point over here going through the coax network on MoCA, and wireless access point directly connected to the UDM. And what's really cool about this is with this model, you basically are allowing the MoCA or coax network to do backhaul for your Wi-Fi network. So if this phone roams around and this phone starts talking to this access point, the traffic from the phone flows through the access point, which flows through the switch into the MoCA network back to the UDM. So what's nice about this is when it comes to Wi-Fi backhaul, you don't have to use meshing. And of course, if you go down the meshing route, you're limited to the number of access points you can use, etc. But basically, now you're just using the coax in your house for the backhaul side of your network, and it works really well. Now, one other thing I want to mention in this kind of complex diagram is you need to think about how you set up your VLANs on your Dream Machine. Now, this is if you're using a Dream Machine. If you're using a simpler like non-VLAN enabled router, you probably don't even need to worry about this. But in the simple case, imagine, out here you have your Apple TV, you have Wi-Fi, you have your PC. Presumably, these may be operating on different VLANs. Like if this PC is in a kid's room, if you watch any of my previous videos, you may want to have this PC on its own VLAN. You may want your streaming devices on another VLAN. And the Wi-Fi access point, chances are you're going to want it to carry all the VLANs, or many of them, because you're going to have phones and other devices, maybe Internet of Things devices on their own VLANs. So that means when you set up these ports, you need to set up the port on the Dream Machine as a trunk port and be capable of carrying all VLANs. So that's just a gotcha, not really a gotcha, but something to be aware of when you set this up. And as I recall, that's how it works out of the box. I didn't have to do any weird configuration with the Dream Machine ports, but something to be aware of as you go forward. So that is a quick logical view of how MoCA might fit into your household. So why don't we take a look at actually what this looks like inside a house. So where we'll start is outside, where the cable services come into the house. From here, wires run to each coax port in the house. You connect all of these together using a splitter, and now you effectively have a quote-unquote network linking all of the coax wires together in your house. So this splitter and bringing them all together is what will allow the MoCA protocols to reach all of the devices in the house. And so this is exactly the same setup you would use if you had a splitter and you're running cable TV service to each TV in the house. Now, one thing to be aware of when using a splitter is obviously anytime you split the signal, you do degrade the signal, or you get the signal has less strength. Make sure you're buying high quality splitters and only split it the minimal number of times you need. You may notice in my kind of messy video here, I have a splitter and there are several wires sitting in the back which are not hooked up. And these are rooms in the house which have coax running to them, but I simply don't need a MoCA endpoint in the house, so I do not connect them to anything, just to keep the splitter to the minimal number of splits possible. And one other note to call out is that it's super important to use MoCA filters on your network. I recommend using two. The first one is on the outside of the house, which prevents MoCA signals from interfering with your neighbors, if you want to be a nice neighbor. I didn't do it for a while and no one complained, but still, it's a good practice to put that on the outside of the house. And then a second one should go right behind your cable modem to prevent MoCA signals from interfering with your internet service. I didn't think I needed to do this, and for quite a while, I didn't run a filter on the back of the cable modem like this. And what I ended up with was a very difficult to debug issue where my internet speed would drop from the advertised 1 gigabit per second to 10 megabits per second with no warning. Sometimes it would stay like that for hours or days, and then it would just fix itself. I had people from the internet company out to measure signal levels. Everything was fine. I thought my cable modem was going bad. I never actually replaced it. I thought it was overheating. I stuck a fan in front of it, made it nice and cool. And in the end, nothing solved this problem. The internet service would just slow down tremendously. I tried rebooting devices. I rebooted the cable modem, the MoCA device. And it was only when I started rebooting the MoCA devices and started seeing an improvement, I started to think maybe I was missing something, and went back, did some digging, decided to drop one of these filters on it, and everything has been rock stable since then. So, all right. That's what it looks like on the outside of the house. So at each point in the house where you want to have a wire connection, you install a MoCA device to the coax cable and then connect the Ethernet port from the MoCA device to your computer or whatever device you want to connect it to. Now, the nice thing is you can put multiple Ethernet devices behind a MoCA device, as I mentioned in my logical walkthrough, using a standard Ethernet switch. So for example, here I have a UniFi switch behind a MoCA device with an Apple TV connected and a UniFi Wi-Fi access point. So in this case, MoCA is enabling the coax cables in my house to function as Wi-Fi backhaul, and this means no Wi-Fi meshing is needed. And so, you may be wondering, does it work? In my experience, it's been fantastic. And I was skeptical at first, given my poor experience with similar products such as Powerline networking. My experience with Powerline networking is probably a few years old at this point, decade old, so maybe it's gotten better. But I have had no luck with anything besides pure standard Ethernet and Wi-Fi. I have been pleasantly surprised by MoCA. I have 1 gigabyte service to the house. I can show you a couple of speed comparisons here on the screen between devices directly connected over Ethernet and the MoCA devices, and as you can see, it's pretty darn good, and it's consistently good. You don't get odd performance dips, and overall the devices have been rock solid. So super impressed. So that wraps it up. A quick introduction to MoCA networking. Highly recommend it if you're looking to enhance networking in your house and you don't want the trouble of running Ethernet throughout your house. It's a great option to consider if you already have coax wires installed. So we'll leave it here. Drop any comments down below and we'll see you next time.